Hello everybody and welcome to the 9th lecture of MIA 320. In this lecture we are going to talk about solid waste management, and by talking about this topic we are going to finish this section which was focused on engineering and the environment, because we talked about climate change, air pollution, water quality control, and today we are going to finish this section. Before we can more carefully consider the material flows and environmental impact of waste, some definition needs to be provided. Solid wastes are wastes that aren't liquid or gases, such as garbage goods, non-durable goods, containers, packing, etc. Municipal solid waste, or MSW, is solid waste from residential, commercial, institutional, and industrial sources, but it does not include such things as construction waste, automobile body, or something like that. Garbage or food waste is the animal and vegetable residue resulting from the preparation, cooking, and serving of food. This waste is largely organic matter and has lots of moisture. Home kitchen, restaurants, and markets are sources of garbage, but the term usually does not include waste from the large food processing companies. Rubbish consists of old cans, newspapers, tires, packing material, bottles, plastics, and so forth. But both combustible and non-combustible solid waste are included in rubbish, but we need to keep in mind that rubbish does not include garbage. Okay. Trash is the combustible portion of rubbish, and generation refers to the amount of material and products that enter the waste stream. Activities that reduce the amount or toxicity of waste before they enter the municipal waste system, such as reusing refillable glass bottles or using plastic bags, are not included. Materials recovery is the term used to cover the removal of material from the waste stream for purpose of recycling or composting. Discards are the solid waste remaining after materials are removed from recycling or composting. These are the materials that are burned or buried. In other words, waste generation is equal to material recovery plus discards. In this slide you can see solid waste management, and you can see different aspect of it, from the most preferred one to the least. Management of municipal solid waste includes recovery of materials from recycling and composting, combustion with or without energy recovery, and finally disposal in landfills. But of course not all of them are the same. Some of them are more favorable and better, and some of them they are not good. Integrated solid waste management this approach is intended to help guide decisions about the generation of waste, recycling of material, and ultimate disposal of waste residue. And this picture, as I mentioned, shows an integrated solid waste management system and outline of some of the highlights shown here. Source reduction, reusing and recyclings in all circumstances are given the highest priority, and it is easy to understand why. To reduce the amount of solid waste that has to be burned or buried, of course it's good. To reduce pollution associated with mining, use and disposal of resources, or to reduce the rate of consumption and consumption of scarce resources. So those are all, there are some aspects of this source reduction. But garbage, before speaking about green garbage and a little bit of green product strategies, let's talk about different aspect of it, because here is a continuous way from source reduction to landfilling, which source reduction is the most favorite one, and landfilling is the least favorite one for us. So here I'm shown some of those important aspects of source reduction. As you can see, reduce toxicity, less packing, product reuse, producing better products, on-site composting, recycling like collection, processing, and reusing, and disposal, so of course landfill and combustion with energy recovery. But you might there is reusing and recycling is a little bit of confusion, because sometimes for reusing some products you need to spend some kind of energy in terms of resources that needs to be into it. For example, if I want to use let's say Pepsi bottles, not the plastic ones, the glass ones, I have two options. I can either reuse them or recycle them. For reusing them, so of course I need to collect them. I need to have a very nice system to check them if they don't have any track, or they are completely safe because people can drink from it. I also need to wash it. I need to disinfect it, and after that I can refill it and send the product back to the market. The other option that I have is recycle it. So I don't need to wash it. I don't need to have a very sophisticated system to check if they are cracked, if they are good for health, is it's in good shape and integrity. I just put everything into the recycling, and I produce a new glass bottle. Both of them, they require energy. So water is a scarce resource. It's not. It doesn't mean that it's available as much as you want. Some countries yes, some countries no. Washing, cleaning, because normally it's a very high pressure warm water or hot water, majority of the time with the steam. So to increase the water temperature, you need energy. So it's a kind of like maybe for some products reusing doesn't make sense, but for so the majority of the products, the reusing is better than recycling. If I want to give you one example, is about beer bottles in Denmark, that they reuse them, but anytime that they wash and reuse the bottle, they need to put a date that they cleaned it and they reused it, and after 10 times that bottle needs to go into recycling because is structurally is not strong enough to hold more process of like reusing anymore. So as you can see here, like on top, garbage that is not produced does not have to be collected. So basically what it's saying, it's simply it's speaking about the source reduction. When it's not produced, it's not does not have to be collected. Here we are going to have to speak about green product strategies. Basically, it's like a design that concerns itself with reducing the environmental impacts associated with the manufacture, use, and disposal of products, is which is very important part of any pollution prevention strategy. For green product strategies, we are going to speak about some aspects like material selection, product system life extension, material life extension, reduce material reduced material intensity, process management, efficient distribution. So we are going to talk about all of them, but first let's start with material selection. Materials selection is a critical stage in product development. In green design, attempts are made to evaluate the environmental impacts associated with or processing, use, and retirement of the material under consideration. So in some cases, substituting one material for another can have a modest impact on the quality and price of product, but can have significant impact on the environmental consequences. So what's one of those examples? Let's say takeaway boxes. In the majority of the countries in the world, they are made of plastic. Is it good for health to carry a hot food? Not really. Can be easily recycled? No. If it goes to the environment, will stay there for 200 or 300 years. Depends. So just like how percentage of the food price is that plastic box, I don't know, like 0.1% or something like that. So for like a company, let's say, not a company, even a restaurant or a small restaurant, it doesn't make any big difference for them. It's just like about the convenience. But in terms of money, maybe if they buy a plastic boxes, it costs them just 1 rand per box, but if they want to replace it with more environmental friendly, like the paper ones, maybe they need to pay 1.5 or 2 rands. So 1 rand per box is not going to have a significant effect on them, but the environmental impact or consequences of that decision can be significant. The other example to show how material selection can impact the environment is using cables consist of steel, lead and copper. By the middle of 1980s, polyethylene had replaced all of the lead that had been used in cables. Such progress continues with fiber optic cables, which are now replacing traditional copper cables, not for electricity but for data, weighing only 3% and using only 5% of the energy to produce compared to copper cables. So just think about that, 5% of the energy required to produce copper cables. Another good example to show the importance of material selection is telecommunication industry, and especially in 1950s that they were products that they were not as environmental friendly as what they are today. So the world is walking towards selecting materials that they are better for environment, but still there are lots of steps needs to be taken to consider the situation ideal. The other aspect is product system life extension. Products that they don't wear out as quickly don't have to be replaced as often, which means resources are saved and less waste is generated. Some products are discarded for reasons that have nothing to do with their potential lifetime, such as computers or clothing. It doesn't mean that you can't use it. They are not up to date anymore. So the fashion, you want to be fashionable. So that's a reason maybe you can use shirts for like 5 or 10 years, but after 6 months you intend to buy a new product. That's the reason why there is a huge industry investment in clothing, especially to reuse the fabrics or even sell the second-hand brand clothes to other people. So those are some products that we are not going to use them anymore, not just because they are dead or they wear out or we can't use it, just because they are not up to date anymore. So for those kind of let's say wooden stuff like a table, for how long you can use it? If you take care of it, there is no year you can put it. You can use a chair or a table for 100 years. It can go even stay in a family. Is there any problem with it? Of course not, because you are extending the life time of a product. It's good for environment, and financially it's good as well. Material life extension. Once a product has reached the end of its useful life, so it means that you've done everything that you could do in terms of like a product system life extension, but that product is done, so it's reached to its useful life. The material from which it was made may still have economic value and can have additional saving. For example, like cell phones. We know that there are lots of rare and expensive materials in cell phones that even though you can't use them anymore, they are not going to send them to landfills. They are going to take some of the material out of it and use it for the next products that they are having. The key design parameter for extending the life of material is answering a very simple question. How easy is that to recycle a product when it reaches the end of its useful life? The other aspect that we need to talk about is reduced material intensiveness. Green design strategies include reducing the amount or toxicity of material required to make a specific product. For example, changes in battery technology provide a good example. In 1974, a typical car battery contained around 40 kilogram of lead, but modern batteries are use less than that, around 9 to 8 kilogram. But you might say that it's not a big deal actually, from 14 to 8, just 6 kilogram per car. But just think about that, if you multiply it by around 50, if I'm not mistaken, 50 to 60 million cars that are produced, you will get a very huge number, but like 300 million kilogram less lead. So that's huge. Another aspect is process management. Manufacturing products require raw material and energy, of course, which both can be managed more efficiently. The energy required to manufacture a product is an important component of a life cycle assessment. Process improvements such as waste heat recovery, use more efficient electric motors or high efficiency lighting systems. In the US, almost 70% of the electricity used in industry is it's because of electric motors. So any small improvement can affect a lot. For example, if we are saying that 70% of electricity used in industries US is used by electric motors. So if you can, or somebody can improve the efficiency of electric motors by, let's say, 1%, maybe US doesn't need to build 1 or 2 more extra power station in the next 25 to 30 years. Yeah, because in terms of like energy, it's all about collectively. For example, maybe for one person or one particular situation doesn't make a very big sense for you guys, but always if you think about the amount of people that they are living in the world, like if everyone wants to do it and follow, or everyone does not follow what it's good for environment, it can have a huge impact. Efficient distribution is another aspect. So methods of packing, transportation products greatly affect the overall energy and environmental impacts which are associated with those products. I don't know if you remember, but in 2000, if I'm not mistaken, yes, 2000, when I bought my first cell phone, actually, like the packing was so huge. I think it was around like the size of like 25 centimeter in 20 centimeter in 10. But now you see that even the boxes of the cell phone is more or less the size of the cell phone, but of course it's thicker, but it's very small. So you might say that, okay, how that can affect. Just think about that. If you want to import 1 million cell phone per year from China or South Korea, how they export it. So of course it's coming with ship. So by decreasing the packing by the magnitude of 4 or 5, it means that the number of ships that they need to come from China or South Korea to bring those cell phones to South Africa will decrease by 500%. That's huge. Just think about the energy that will be saved. So packaging and especially the sizing, and after that the consequences of that into transportation industry is huge. Reducing the amount of packing. So with one example we made it clear that can reduce the environmental cost of distribution. Besides that, using recycled material for packing along with strategies that reduce the amount of packing can contribute to reduce environmental life cycle costs. So now it's just not about the size, it's about the less packing or using recycled material. What does it mean, less packing? For example, sometimes you buy things that you realize that they could be less, they could use less material for the packing, and during the transportation nothing would happen to the product. So those kind of designs as well. So if you can go smaller, you need to go. If you can use less material for packing, you should do it. If you can use recycled material for packing, you should do it. But of course not all the times those are possible, but in majority of the time, if there is like a good thinking behind it, they are achievable. Now we are going to talk about the waste management, energy and greenhouse gases. A life cycle analysis of greenhouse gas emissions must cover a long series of steps, from extraction and processing of raw materials to manufacture of products, transportation, waste collection, recycling or composting, and finally how we manage the discards that end up in landfills. At every step, from extracting of raw material to waste disposal, there are greenhouse emissions that and can be affected by solid waste management decision. Greenhouse sources are normally from 5 major factors. There are either from fossil fuel combustion emissions, non-energy related manufacturing emissions, methane emission from landfills, methane, carbon dioxide, nitrous oxide emissions from waste combustion, carbon decomposition in materials that are stored for a long period of time in landfills. So all of those are major factors of greenhouse sources. Translating emissions as well as carbon sinks into equivalent greenhouse gases require a careful analysis of the energy inputs as well as the types of greenhouse gases that are emitted. Non-carbon dioxide greenhouse gases are weighted according to their global warming potential. The 100-year GWP or global warming potential of methane, for example, is 23, which means 1 ton of methane is equivalent to 23 tons of carbon dioxide. Very low in terms of volume, but in terms of impact on the environment is exactly the same. The usual unit for a mixture of greenhouse gases is metric tons of carbon equivalent, that we call it MTCE. MTCE is expressed as carbon since the molecular weight of the carbon dioxide is 44 and the atomic weight of carbon is 12. 1 metric tons of carbon dioxide is equal to 0.273 MTCE. Okay, so energy implication of solid waste management. You can see here again is from most desirable to the least one. Again, reduce, reuse, recycle or compost, recover energy, and at the end is landfills. Recycling, just explain it a little bit, but we are now going to talk it a little bit more, is after source reduction, recycling has the highest priority. Resource recovery or recycling means that the material must not only have been removed from the waste stream, but in sense must be purchased by an end user as well. The process of collecting, separating, processing of waste stream products into new forms that are sold to manufacturers and finally purchased as a new product with reprocessed material. Paperboard recycling, this is the largest single category of waste generation and waste recovery. In 2008, that now it's much higher than that. 84 million tons of paperboard disposal was generated. Just think about those online shops you just buy 3-4 small items, and after that they come in a huge boxes, and what would happen to those boxes? You just like throw them away. And in now is around maybe there are some concerns regarding that, but the good thing is, at least in terms of paper board, the majority of them, they are going to be recovered. Most consider that the recycle life of paper is not infinite, and of course the quality, it won't be the same, because after each time of like a recycling, the paper will lose its quality, and every time it can be used, if we recycle it, with can be used for less important or cheaper products. Recycling plastics, the plastics, the disposal of plastics increased significantly during the last half a century, because after the plastic boom is after World War II, that they wanted to make everything with plastic. Its environmental consequences were not that clear during that time. So lots of companies, lots of government invested on plastic, oil-based plastics, and after that, now in 2020, we know all the consequences of plastics. Even now they found plastic in marine life, inside the fish, especially the small pieces of it. So there are everywhere, and even some countries in the world, they have a regulation to manage the use of the plastic, to decrease it significantly. So what you are, it's not very common here in South Africa, but in other countries around the world, the majority of the shopping bags are paper, they are not plastic. So they are trying to find a ways, very simple ways, to decrease the amount of plastic that we use. Glass recycling is like because the glass usage actually decreased over the time in industry after introduction of plastic as well as aluminium, especially for drinks containers. Is the use of glass stabilized at around 13 million tons per year, and the recovery rate of it in US is 22%. You might say that it's a little bit low, and I agree with you, because 22% is just like 1 out of 5 bottle will be recycled in US, but a part of that low percentage is about reusing as well, because when you reuse something, you are not recycling it. And the other reason, it's because the glass recycling process is very energy intensive. Aluminium recycling, especially like drink cans, they are the most valuable collectible, so they worth much more than the plastics. They compromise of only 2 to 3% of total tonnage of recyclable collected. They generate in order of 20 to 40% of total revenue. So you see they are just 2 to 3%, but they can generate between 20 to 40. So that shows that how valuable they are. It's estimated that 95% of recovered aluminium goes back into the generation of new can, which is really good. It's a very high recycling percentage. Other metals, so you can see it's like in refrigerator stuff in the kitchen that normally you change every 10 to 15 years time. So there are lots of toxic metals in those products as well. So I think the rest of that's it for today, because we are already 40 minutes. So the rest of slides I'm going just to upload it on ClickUp. The rest of slides are for self-study, and I think it's the last lecture that we have before the semester test. Please study hard and good luck with the test. Enjoy the rest of your day. Bye bye.